Hello, guys. This is Matheus, and I'm here to present the paper Generative Agents, Interactive Simulacra of Human Behavior, which is a paper that got kind of some reaction from the media, right? So here you can, if you look here in the paper, look into the news, you can see that appeared on several news outlets, right? So have even blog posts related to data scientists, but also sites like Hero Vice, TechCrunch, and here PC Gamer, right? So it's really, for some reason, I guess, because of this art and how it uses AI to get, to simulate, do a simulation of humans. I think that kind of caught the attention of some people. It was a paper that for LLM standards, I guess a bit old, right? It's like from last year, April last year, and I think some also parts show that because it's based on ChatGPT, etc. But basically, this paper introduces what the authors call here generative agents. So it's like computational software that makes agents that are believable, right? And they also created this sandbox environment, right? So you have like agents, like it's 25 agents. I will explain more later, but it's like 25 agents that are like humans, and they lived in their houses, but they also have to interact, like they go to stores, they have to go to universities, etc. So and they they do some interactions between themselves, and the authors were able to try to measure some emergent social behavior from the agents, right? So not only like that the agent itself has some believable uh, set of actions, but also how it interacts with each other agent, if like and they try to measure some stuff from that. Okay. Uh, so here, so how they, like I said, they created these generative agents, what they call, and here they say that they describe in this paper the structure, basically using large language models. So they store users' past experiences into a memory stream, and they synthesize like the memories and how which memories to choose from to make a planning or to do a set of actions, right? So here, like I said before, they instantiate all these agents in an environment, a sandbox environment with 25 agents, and they try to measure some stuff from that. And here they say like, for example, like how they measure this social behavior. Here they start like with only one agent that wanted to throw a Valentine's Day party. This agent was able to transmit the information to other agents. So she sent invitations to other agents, and then in the course of 2 days, the agents make new acquaintances, and this party actually happens, right? So some people actually do participate in the party, which is a thing that it was not hard coded, right? So it was happen on its own. And then here they demonstrate, right, through some ablation tests that the main components of the architecture, that's it, the observation, the planning, the reflection, right? So how you observe your environment, how you plan your next steps, and how you reflect on your own steps. Each one of these components that the authors created, they help to make a more believable agent. Okay, so here first they introduce a bit about how like how you can craft a believable agent that has a human behavior. And here they say that basically, these agents, they must act consistently, right, with past behavior. So, and then they could be used potentially, they say here, like, oh, you can use to train people to handle some specific circumstances that may never happen before, or you can use these in virtual environments as, like a training guide, or even like you have a multiplayer game, you could have like agents that simulate they are not real humans, but you have a fuller experience, right? You could have like a city maybe, and then you have some players on the city, but each inhabitant of a city in the game could be an agent that's believable, that has some memories, right? Of course, you have this in games, you have the NPCs, but I think here the idea that they say is, I think that's more deep, right? They have some memories, they have some actions that's not hard coded, right? Uh, uh, and then they say here that the success for the agents, they require that not only some hard coded. Here they say all this the points of the architecture that they created. So that's that, but makes sense, right? So they have to retrieve some past events, so they have some kind of memory. They have maybe to reflect on this to see like thing is relevant or which thing is not relevant, and what maybe new new stuff, how this impact on their future planning, right? Because they also had to do some planning, right? So it's like, oh, I need to do this, or I need to do this, or oh, something happened, so I can't do this, or maybe I should visit this person because this person, I know now that he is you, for instance, right? So planning and reaction is a thing that the authors argue that will improve to make more believable agents. So here they go here, I'll introduce generative agents that based on LLMs, try to create agents that, produce believable simulacra of both individual and emergent group behavior. And here they say that these agents that they created in the sandbox environment, right? This, like a game here. They create plans, they reflect on their characteristics and experiences, and they plan and react when appropriate, right? Here they also say that they can also respond to user response, right? So say like, oh, you can add some stuff like, oh, you want to do this, and then the agent internalizes that, oh, I want to throw a Valentine's Day party, or oh, I will be running for an election. Of course, they use this to add some information so they can see like how this information is spread, etc. Uh, so to enable these agents, they describe some architecture here that stores, synthesizes, and applies these memories using LLMs, right? So like I said, they use ChatGPT here in this case. I mean, GPT 3.5, right? Not directly ChatGPT, but okay. So the main components here, like first is the memory stream. So how you store past experiences, right? So this is very important because LLMs, they have a limited context window. We have now LLMs that have very large context window, but I think the way they do here also filters some memory. So they try to filter and get only the most relevant ones. So this may deal a bit with model hallucination and so and stuff like that. The second part uh, is reflection. So basically, is like given the set of actions is kind of like an inner thought, like, oh, what I'm doing currently, or what I'm like, what's happening right now. So it's like he's not interacting with other agents or stuff like that, but he will reflect and try to see which is the case that he needs to the next set of actions or what is happening. And the third is planning, which basically is like how the agent will plan its say in the future. So like, oh, I need to eat now, or I need to go to sleep. In my next day, I will keep on studying my paper that I'm writing, right? So it's a bit like that. Here they had some recursion to try to make it more believable set of actions, but basically these are the three main components. And then they run a simulation and they demonstrate that it's sufficient to just tell one agent, like I said, like some information. So I want this agent like, oh, you want to throw a parry. This information is enough for the agent to start inviting other players, not other agents, start doing some preparation, and the party actually happening, right? So you can see that you have some information diffusion, right? So you start with one person knowing stuff, but then you have a set of people that start knowing about the party, and some people even start go to the party, right? So it's the thing that was not planned at the beginning of the simulation. And they say here that it has like several points of failures, but actually it does succeed. It's not perfect, but yeah, it succeeds. The party happens. And then they do like here they explain like there's some technical evaluation. So like how they will evaluate like the knowledge, the information diffusion and stuff like that. So they basically do an interview with the agent. And yeah, and then they also try to evaluate some errors that arose from that. So basically, in this paper, they introduced these generative agents, the architecture that they did using LLMs to make these agents, and some way that they try to evaluate them. Basically, they are ranking on more believable to less believable. So for related work here, they talk a bit about human AI interaction. So basically here we have like some sets here, they like how we can interact with AI or how this is done. I think it's really simple example, but then here they go like, I think this is a, uh, not this one, but I saw other ones about how to facilitate labeling of our images, right? So here we have a case that we have a hand in the foreground, and here basically you just draw here a bit about like, oh, I want to get this and not that, and then you can see that by interactively going through is able to get some labeling, and this could be used to label further images, right? So this is a more basic approach. But I think, like since last year, things that is really important is this interaction. Like for instance, image generation, right, or image editing, right. So you have using natural language, you can probe a model to do some stuff, right. So like, oh, replace this with cake, okay, or oh, add new clothes. And I think like you also have like Mid-Journey, right, that you give a text and then it generates an image, and that is very, it follows like what you describe. Like if you're very specific, you are able to get images that like kind of like tailor-made. And likewise, you have the opposite. You have like, if you can give an image and the model can output like some text that is very descriptive, right? So now we are getting this point that the interactions between humans and AI, it's getting like, it's not only direct like some programming needed, but you can also try to probe more directly, right? Okay, basic. Then they go to believable proxies for human behavior. Oh, so basically, like how you make an agent that is believable. Uh, so here they say that the ideal would be like an agent that not only has some actions that is they do are that are believers, so they're not hard coded, but also they're able to understand and get like and change behavior midway given some happening, some stuff that happens, right? Some new actions that happens, right? And then here they say like creating NPCs with believable behavior could increase, the player experience or how he's emerged into a narrative or any other type of thing, right? And then they talk a bit about the most basic agents. They say like rule-based approaches. So have finite state machines and behavior trees. That's it, right? You have a tree and then like, oh, if this and then do that, if that, do this, right? Account for brute force approach for human altering the agent behavior. They talk a bit about how this is not that good, but I think it's interesting to think, especially if you don't know a lot about how that works, especially for agents. I think you have this, especially because the paper they describe, as a the scene simulation, right? So have the paper here, and then like, oh, it's kind of like a the scene simulation. I think it's interesting to at least explain a bit about how the scenes work, because I think it's very simplistic. There's some stuff that really this paper has more potential, right? Especially this part of natural language and how agents can interact between themselves. But also there's some stuff that I really think that they could make use of what the scenes does, right? Which is not that simple, right? They say here like, oh, finite state machines and behavior trees. It's not only that. They go a bit deeper on that. This is a presentation that I found online, so really I just found online. So I just go into a bit of things that I think is interesting to think about, like how we can model not intelligent but believable agents in some way, right? Even though it's very simplistic. So basically here they talk a bit about what is The Sims, right? So The Sims is a game that was created by Will Wright, right? First he created Sin City. I don't know if you guys know about it, but it's you're like a mayor, and then you can create a new city from that. So you have to do some city planning, and then like the city grows, and then you have to deal with taxes and how you do that. So it's very interesting game. They have seen Ant, it basically was the first one for live things, I guess. So basically you simulate a colony of ants, and then you have The Sims, which is, I think, is maybe is the most famous game that basically you have agents that are humans, right? So it's not like a macro level like a city, but it's more like individual level. So you're like in a village, and then you have your character, and then you interact with other characters that live in this village or city, right? Okay, so let me just someone said something. Oh, okay. Okay, so very brief, right? I just played very briefly The Sims, so it's not that I'm very good at it. But basically, what is The Sims? So it's a sandbox game. So it's 3D, but I think it's very similar to the image that I showed earlier about the paper, right? So you have like a village, you have your house, and then you have your player, and then like it's kind of like a God's game because you have this third view approach of the game, right? So you view from above, right? So it's more like it's kind of like your God, right? So you see your character and the other AI characters, right? So it's more like a live simulation, right? And here basically the player controls the life of a family of scenes, right? So you have your scene, and then you have scenes that live your neighbors and people that work on shops, etc. So basically, you have the player. So basically, you can design your own characters. You can design your house, your buildings, and then you can give direct order to your characters. But then you have the computer that has to do all the hard work because he has to work with all the other agents, right? So, and also control some of the game mechanics. And then they talk a bit about like how the pathfinder, so how they walk through in the city, but not the scope here. And then they also have this free will, which is interesting, right? So what is the free will that they say here in the scenes? That basically, until you give an order, the scenes they can survive by themselves, right? So it's not like you're playing a game like a GTA game that you leave your controller off, right? You go to do something else. The character will stay still, right? Maybe he'll get arrested for some reason, but the player will stay still, right? And here, the scenes they kind of add an auto mode that you start doing some stuff automatically, right? But then he decided, they don't play too well because you have to give some incentive for the person to play right directly. So I think most important interesting things here I think related to this paper is this decision making and social interactions. So basically, in decision making, the agents work. They have like some needs, and then they have like some happiness meter for each need. So they have to keep all these needs meet, so the agent don't get angry or frustrated, right? So you have some physical and mental needs, right? So have hunger, so you solve that by eating, and then it also have some set of actions that will help with this need, right? So have your hygiene, you can take a bath, and then you have energy, you can sleep, right? Or you have fun, you can start playing some stuff, right? So you have like different set of things and how they go and they decrease over time, right? So if you eat something, maybe you're not hungry, but then as time goes, you get more hungry, right? One thing here that I think is interesting to think about is that they model it very simply, right? So it's just a function, and then over time it changes the value, right? So here, like for instance, hunger, you can, if you eat, you go to plus 100, but then over time, you get you get more hungry, right? And I think it's interesting to think about that they use different set of functions here, because like oh, being a little hungry is okay, right? But then get a time that you are starving, so you really need to eat, and this is a very strong need, right? So a person really, oh, I really need to eat, or I'm going to pass out. And I think it's interesting like how they model, right? Because it's a different set of functions. They could be just be monotonically linear, right, descending, but I think they try to fit stuff. And then there's stuff that I think is kind of interesting, like the fun part, right? Playing stuff, like, oh, you may need to play when you have a lot of time passed since you last played, but when you're playing, you want to play more, right? I think that kind of makes sense. It's very simple, right? Because then you could say, oh, the person can get, like, oh, I don't want to do this anymore, and this kind of doesn't model that. But I think the main part is that it's a very simplistic approach, and maybe it kind of produces believable behavior, right? Of course, it's simplistic, it's hard coded, but I would say that it's kind of believable. So basically here, to not make the things too mechanic, they choose randomly. So they try to rank the set of actions that is possible, and then they try to maximize the ones that get more happiness, right? So like, oh, eat toast, eat cereal, and then they try to pick some of that, right? Okay, I think basically that's the thing. And I think maybe some of aspects of this could be added to the paper that I'm going to present later, especially the downfalls. And I think the other part that I think is interesting here is like the social interaction, right? Which basically is like the paper says, like is a finite state machine, right? So basically you have a relationship score with every two pair of things, and then you have like, oh, first you start as an acquaintance, and then like if you lose some of that, you can become an enemy, but then if you get to know more and can become friends, and then even a crush, right? So it's very simple. And I think this is like one of the things that could really improve the paper, because as you see later, the interactions can be kind of mechanic, kind of robotic, I would say. Okay, okay, now back to the paper. So here they say that, okay, and not the less, it's very if you do hard coded stuff, it's kind of like it's not, you cannot perform like new sets of actions, so it's not believable, which is kind of true, right? Like how you cannot perform new procedures that were not hard coded in the script, so that makes sense. But I also think, like I said, I presented this the same because I think it's has some stuff that is of the interest, right? It's like you don't need to be as perfect to make believable agents, right? Another thing that they point out is reinforcement learning, right? So you have lots of here AlphaStar, OpenAI, like all these models for DeepMind that were able to beat humans in a set of games, right? Computer games, but also have the uh, AlphaGo, right? That won against the Go World Champion, right? Which performed superhuman behavior, but one point that they put here is that their success is largely taken that it's adversarial game, right? So it's very easy to compute some metric of, oh, you won the game, you lose the game, or you are in an advantage position, or you are in a disadvantage position. So it's kind of possible for the agent to play against itself and again keep improving the behavior. And also, I remember reading the news that some of the strategies that the agent did were not really comprehensible to humans. They were like, it works, but I don't understand why. So maybe would that be believable human if it beats the human? Is that enough? Or it would be better to have an agent that is more limited, right? In this case of thinking about human believability, right? But okay, so here, but like I said, these are adversarial examples, so it's not really that good to model one agent, right? At least you have some limitation, right? We need a lot of training time, and then maybe they need human interaction, right? Okay, so today they say here that creating believable agents is still an open problem, because you have lots of things that can play into that. And the argument here is that now that we kind of started with large language models that are really powerful, that we can query and talk like in natural language to do some task. It could be used, these large language models, to try to build some believable agents using that. And they say that they offer some step towards that. And then they say a bit about large language models and human behavior. So here they basically say that, oh, if you prompt a very defined prompt, the model is able to generate some believable approach, right? So for instance, like if you ask like ChatGPT, like, oh, explain to me machine learning as an Italian gangster, the agent will kind of be able to write, right? Oh, hey kiddo, you need to do that, and then stuff like that. So it's kind of good for that, but also it's not perfect, right? Uh, So here they also say that the agent is also able to decompose some exon sequences, right? So if you give a task, and if you prompt like, oh, try to break it down how I would make soup, right? And then they say, oh, start the oven, oh, put water in pan, put pan at the stove, etc. So it's able to do that, right? Uh, but one point of attention that they have is that believable agents, they require some conditioning of what the current state is, the current environment is, but also their past experience, right? Which can be a poor fit. I think now, since the paper was released, you have more large language models that have more larger context windows. But I think that's still a point, right? You have to fit all the information in a context window, and maybe if you fit everything, maybe it's not that good if you fit less information, but the information is more related to the problem, right? So say here the paper stands this idea to create the agents, right? So generative agent behavior interaction. So basically here they say like, oh, instantiate the characters in a sandbox game that reminds the scene that I just explained a bit, the AI. So basically here, I guess you guys can see. So basically you have like houses where some of the agents live. You have some agents that live in a college dormitory. And then you have like some stores, and then you have a park, and then you have lots of places of interaction, right? And inside of each place, you have like a house, you have a bathroom, have a kitchen, and then inside of each of these places, you have some specific objects that the agent can interact with, right? So you have table, bookshelf, and then inside the kitchen, you have stove, you have a fridge, etc. And 25 agents, right? So 25 agents that live in different houses, etc. So basically here they explain a bit about how they created these avatars. So at the start, they write one paragraph for each character, so kind of describing its persona and what he does and what is his relationship with some people that he already know. So, for instance, we have him Jolin, that like, oh, he's a farmer's shopkeeper. He lives with his wife Meilin, and also his son Ed, and then he knows this, and that people, right? And then like how the agents interact with themselves. So basically, uh, they interact with the word and between themselves with by natural language, right? So basically, you have some statement, and then this statement is translated into an action by the sandbox engine, right? So like, oh, if receives that is doing like is writing on his journal, so you have like this set of emojis that describe that she's doing an action, and also you have the objects, right? So like, oh, you're doing coffee, Isabella is doing coffee, so the coffee maker state will be turned on, etc. Right? Again, the agents communicate using full natural language, and then they are aware, so they receive information like, oh, you are in this room, and then in this room there is these people, this and that people, and then like and then you prompt the LLM prompts like, oh, do you want to engage in conversation and stuff like that. Okay. So here also they have some controls, right? So you can add like a user running the experience can also add some stuff. like I said, like an inner voice. So that's why how they use like, oh, you are planning to hold a Valentine's Day party, or oh, you plan to participate in the upcoming elections. So basically, you have a user that can add this like a god, right? And then they see like what happens from this set of information. So the environment interaction. So basically, they call this place right Smallville. So they have, like I said, they have like have places that are public places. They have their own houses. They have some stores, etc. So basically, here the movements of the agents are generated by the agents at the sandbox. So basically, the agent will dictate like, he wants to move to this place. So the sandbox environment gets this information and transforms this into a set of actions in this world, right? So like, start moving the agent, right? Okay. Like I said here, like end users, like they can rewrite some parts of the environment. So basically here, like, you can set the status of like here, Isabella shower. So have the shower and then like, this shower now is leaking water. And then when the agent enters the room, hopefully the agent will see that it's leaking water. And then we'll try to fix it, right? So we have this part of them. Okay, so now on the example here, that is they call here the day of life example. So here I try to merge this stuff. I think it's easier to see because they have this image, right? So basically you start with that single description, the paragraph, and then from that you have some mechanisms to start planning how the day will be, etc. I think I'll explain a bit about that later. But basically, with that planning, the agents start, their days, and then they can start doing some routine and then some interactions between themselves, right? So in this example here that they have here the family of Lin family, right? You have John Lin, who is the father, Mei Lin, which is the mother, and then Ed, which is the son. So basically here they show here that first, John wakes up. I think it's a kind of small, right? But basically, he is here. Like, so he starts brushing his teeth, and then he takes a shower. Then he starts cooking breakfast, and then eventually the other agents wake up and then start doing some interactions. So basically, here you have like first the set of actions that John and Eddie, his son, get. I will read just these ones from the paper because I also recommend reading because to me they are very funny how unnatural they are, although they are believable set of actions, right? So basically you have like the father saying, "Good morning, Ed. Did you sleep well? Good morning, Dad. Yeah, I slept great. That's good. What you're working on today?" "I'm working on a new music composition for my class. It's due this week, so I'm trying to get it finished. But I'm having so much fun." "That sounds great." Which, like, father and son relationship really strained there, I guess. But then Ed heads out to school, and then his wife May wakes up and talks with John. And then May asks about her son. And I think the important part here is that John recalls the conversation he just have with them. So like, so again, like May. So his wife said, "Did Eddie already leave for school?" "Yes, he just left. He is working on a music composition for his class." "Oh, that's wonderful. Tell me about it." "I think he's really enjoying it. He said he's having a lot of fun with it." "That's great. I'm so proud of him." Again, very unnatural, the texts. But I think the main part here is that uh, you're kind of able to see an example of information diffusion from the agents, right? Because you have a set of information that only Ed knows, right? This music composition that he's working with. He talks with John, his father, and then John is able to pass this information to May, right? So you can see that what only one agent knew, now the three agents on the household knows about it, what he's working with, right? And then later he say like, after the conversation, May and John pack up and they move to the places that they work, right? So the agents go on with their lives, right? Although the text is very weird, the interaction, right? But it kind of works, right? I think that's the main point of the paper. Okay, so here I get here, and then I think again they explain a bit about what they are trying to measure as emergent social behavior to see if that actually happens or not. I think basically on given the interactions between agents, how they talk, their actions, right? So basically, there are three things that we're trying to do. So first is information diffusion, which is the example that I just said about, right? So information that only an agent knows, and then this information is spread across agents. So the one that they have, for example, is that Sen is running for election. So basically, only Sen is knows about that, and then he starts talking about the other characters, like, "Oh, I intend to running for the election," and then they start discussing about that, and then they are trying to see like how many people, at the start of the simulation, only one people knows about this, and then at the end of simulation, how many people will know about it as well, right? They will recall this information. The second one is relationship memory. So basically, you have some people that, 25 people, they have some households, like the example that I just talked about, but some agents, they may not know each other, right? So basically, it's like, are they able to form new relationships and then recall that, oh, I know this person does that, and that were not given before this information before? And third, and I think this is more interesting, is the coordination, right? So how agents can coordinate with themselves. So, for instance, the main example here is that Isabella, it's initialized with the intent to holding a Valentine's Day party. And then from this seed, the agents, like she proceeds to start inviting people. She starts to preparing stuff, buying stuff, and then they try to see if at the end of the simulation is only 2 days. If at the end of the 2 days the party actually happens and people actually show up, right? And here is an example that actually did happen, right? So at the beginning of simulation, only Isabella knows about it, but then at the end, at the time of the party, like some agents appear in the party with her, right? So not all of them, but some of them, which I think it makes sense, right? Okay, so now about the architecture. Bit, uh, so basically, they say that you need some mechanisms to be able to make believable actions, and without these mechanisms, like it may don't have memory, so it may not maintain long-term coherence, right? Uh, let's see here. Yeah, and then here, like, so since these large language models produce large string of data, they need to have a way to keep track of memory, and especially try to get like what is important and what's not that important, right? Because there's some stuff that it happened, but it kind of don't need to pay much attention, right? So here they say here at the center of the architecture is the memory string. So basically, yeah, so here we have basically the memory string here. So basically where it keeps all the set of actions and what happened and stuff like that. And then you want to have like some part that you want to be able to retrieve information from this memory string. And then with these retrieved memories, we have the part of reflection, right? So we have like I said before, it's like an inner thought, right? Oh, this happens, and then what, and then why this happened, and try to understand a bit more. And then the planning part, which basically is like giving this set of information, like how should I plan my day or my next set of actions? Like, oh, I know this person is ill. Maybe should I visit, like with this new set of information, like he plans on doing that, right? Okay. So the agents basically, like I said, they were done with GPT 3.5. So maybe you have newer models that they are better, or they have larger context windows, right? Because I think it really affects the memory stream. So first part is the memory retrieval part. So basically here they argue that the challenge is that you need to make a believable agent. You need to have like some memory, right? Because it's not like you're a fish and then you don't have past experiences, right? Especially if you try to hold a long interaction between an agent and a human, right? But then they say here that as the context gets longer and longer, this may not fit inside a context window for a model. Of course, like I said, some newer models have huge context windows, but still, I think they also have the issue that if you have, even if you put everything fits in the context window, the model may not be able to get like, oh, what's really important and what is not that important for the current set of events. So they try to build this memory stream that basically wait a minute, let me read here. Uh, oh yeah. So yeah. And then also another thing that they say that if you just summarize the events to fit in the context window, that may not be that important, right? Because the large language model could summarize and remove some stuff that is really important, and then they keep stuff that's really unimportant, right? So it will degrade the information quality, right? So instead of summarizing, they try to build a different approach here. So basically, you have the memory stream that you have like some event or something that's happening, and then you have a timestamp with that, right? Uh, So, and then you could be like stuff like what the agent is doing, or one object, what is happening to the object, or like one what other character set. So this all fits into the memory stream. Uh, Here, yeah, like it's basically what I said, right? Summarization and informative. So you create a memory stream for all the events with timestamp. So it can be things that are made by the agent itself or behaviors that the agent see being performed by others. And they try to create a weight to score the more important information or memories, right? So they have three factors. First is recency. So basically weight that in relation to a timestamp. So it's like an exponential decay. So things that are more recent, have higher recency score. The second one is the importance. So basically, they use the LLM to score if the memory is important or mundane. So it's another thing that's kind of like they say, like, oh, I don't know here. Isabella Rodriguez is stretching, and then they say, like, is this information very important in a scale from 0 to 10? This information is very important or is mundane, right? So they use this to try to score that. And third is relevance. So they use the LLM to assess if the memory is relevant to the current situation. And they use embedding. So basically they have the current situation that is happening, and then they do a embedding search, right? To see like which are the most similar embeddings in regards to that. And then they try to see if that is relevant or not, right? Or so say like, oh, is this memory relevant to this past event or not? And basically, they score this is basically like they have some weight associated to each one of these factors, right? So recency, importance, and relevance. And then they score the memories on this metrics, and they use the top ranked memories into agent context, right? So instead of fitting 150 different events, they fit like you know 10 different events that are important, right? So here, like what you're looking for the most right now. So you have like Isabel Rodriguez decided to plan a party, ordering decorations for the party, research ideas for the party. So you have some recency score, how important that is, and how relevant to the party, how relevant is like for what she's looking forward to, right? And then they weight that down, and then it gets a final answer, right? So basically, this is the first part. And then they have here reflection, which basically, if you fit only what's actually happening, the agent kind of struggles to generalize and makes inferences, right? Because it's like he only sees stuff, but then it's not like, oh, why this is important or not. So basically here in this case, they have like a set of actions, and then given some condition here, like, oh, We generate reflections when the sum of importance scores for the latest events passes a certain threshold, right? So here we have some observations that happen, like, oh, Klaus Miller is reading about gentrification, is reading about human design, and then they generate a reflection that Klaus spends many hours reading, which, okay, but it kind of interesting, right? Because you can see like, oh, this is going to happen, and then like, oh, I do intend to go to the party, for instance. That could be a reflection, right? So basically they query the large language model with the 100 most recent records in the agent memory, right? So this is like they get all the memory string, right? The most recent memory string. And again, they prompt the large language model to allow, given this information, what is the three most salient high-level questions you can answer given these statements, right? Which is, again, maybe improved, maybe with a bit of prompting, right? Because like three most salient high-level questions. But again, it kind of works, right? So it's able to get like information about the agent, and then like stuff, and then you can also generate some explanation, right? So like, oh, Klaus, have some statements about that, and then like, oh, which insights can you generate from that, right? So I think again, you use large language models, but then you try to get some stuff that generate uh, what maybe the agent is thinking in a way that it fits again into the memory stream, right? It's a reflection, it fits into the memory stream. Okay, and then the last part is planning and reaction. So basically how you can generate a believable set of actions that the agent do, right? Because it's kind of challenging, right? Because you have like, oh, this guy works at the grocery store, and then, okay, he works at the grocery store, but then what he does later, what time does he eat, etc. So basically, here they try to plan a future sequence of actions based on maybe past behavior or also like the initial prompt, right? And then here, like the plan includes a location, a starting time, and a duration, right? So you have like what you're going to do, where, and for how long, right? Uh, and then like reflections, the planning are stored in the memory stream and are included in the retrieval process, right? So they know like if a person like, oh, are you free today? And they say, oh no, I have to work tomorrow, right? They can kind of input that, right, in some way. But then they also can update this, right? So like, oh, for instance, like when the party, like Isabella invites the agent to the party, he may knows that, and then he'll add this to his plan, right? So maybe he wouldn't do that, but he adds like, oh, participate in the party. Okay, and then they add some parts here that would be interesting to break down, right? So instead of like, oh, you're going to paint, it's more desirable to have like, oh, you're going to get materials, mix paint, take breaks, etc. Okay. Yeah, so basically they give like some set of initial prompts, and they say like, oh, Ed Lindsay started a new composition, his work, da, 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 da. And then here's the schedule for the days. Oh, well, this is what he did yesterday. So woke up at 7 a.m., da, 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 and went to sleep at 10 p.m. And then like, oh, today is the next day. So here is Ed plans in broad strokes. So basically, they generate first a very broad stroke. So like, oh, you're going to wake up, he's going to the college, and then he's work on his new music composition, then have dinner, and then finish his school assignments and go to bed. Okay, that's a lot of things, but then it's kind of very space. So they break down each one of them like to get more believable. Like, oh, go to school to classes starting at 10. But instead of only that, like, oh, he goes to school, he takes the class, he goes to the bathroom, he talks to teachers. So they break down each one of these big chunks into smaller chunks until it's like 5 to 15 chunks, right? Here they talk a bit about reaction and updating of plans, right? So like, oh, should John react to this? And like you have like some set of information of what's happening, and they're like, oh, should John react to information or should he not? The context here, and then like here they say like, oh, they get all the, when the agent interacts with each other, they have all the information that they have, but also like what is going to happen. So they try to give like not only what's happening in the chat, right? So like John said hi, and then like no, you have like John is this person, and then he knows this, he know about that. He is working on that, and then like John said hi. How you continue with this, right? Okay. Okay. So basically here they talk a bit about how the sandbox works. So basically they use a JSON, and each JSON describes each object, and each object has some state that can be updated or not. And then here they talk a bit about, in this section here, from structured word environments to natural language and back again. They talk a bit about all the set of actions is used in natural language. And then they use like a tree structure to describe the word. So for instance, here, I think, like you have like house. Instead of node house, you have the places like bathroom, kitchen, common room, bedrooms, garden. Instead of inside of each place, you have maybe a set of objects. So inside of kitchen, you have stove, you have fridge, etc. So it's kind of like a tree. But then again, they go back to natural language to describe the environment, right? So like they say here, like, oh, you are in Adeline bedroom, and they have desk, and they have bedroom, etc. Okay, and then they also give a set of like places that the agent knows and what he doesn't know. And then like, and then they prompt like, prefer to stay in current area if the activity can be done here. And then like, this is the activity. And then which area should he go, right? So basically, when the agent performs a thing, he performs like, oh, where should we perform this action, this next set of actions? Finally, I'll get to, oh my God, we'll get to evaluation. So how they evaluated these agents, or how believable these agents are. And especially, I think the most important part is like, did the social events, the emergence of some like information diffusion, etc., did that happen or not, like, in this control evaluation? So basically, they run the simulation over just 2 days, and they try to see like how believable the set of actions are, and how what actually happened, right? So how they evaluate the agents? To evaluate the social behavior stuff, they interview the agents at the end of the simulation to try to probe the abilities to remember past experiences, or to check like the set of events that happen. So like all the information, they get some new information if they pass new information and stuff like that. But then other thing that they have here is the believability, right? So that will be a central part of the work, that they also try to see like, oh, how believable this set of actions were. And then they have like here, so they have here like 5 areas that they ask the agents. So self-knowledge, right? So like how they were able to introduce themselves in a way that is consistent with the start of simulation. The memory, so like they're able to get new stuff and remember stuff that's happened, right? So like, oh, do you know this new person that you actually know during the simulation, or who is running for mayor? Plans, so like retrieve their long time plans to see if it's consistent, the reaction to new stuff, and how believable they reacted, and then the reflection, right? So like how did they got deeper reflections that were made sense. And then here they also recruited human evaluators, etc. And then they also had a human, I think, a human baseline as well, to try to build from that, to try to do some comparisons. Uh, and they also did some ablation tests. So basically they have, like I said here, the generative agents, they have like the 3 main parts, like the memory stream, reflection, and planning. So they try to remove some of set of actions from that, and they wanted to see like they would score again this information, and see like how believable an agent is, and see like how the impact of each part of the architecture is, right? Okay, and they added here, like I said, a human crowd working in role play, that basically he would receive, this person would receive the information that's actually happening, and then he would be prompted to write I'll write this next set of action for this agent and stuff like that. And then they use here. They say here that it's not to be like they're crowd workers, right? So this is no way, shape, or form like a baseline for humans. It's not that is better than humans. It's just that humans doing like they're doing like treating this thing like a job and how they would perform, right? So yeah, I think it's very, very important, right? It's not superhuman, although the image shows that it's superhuman, right? But it's just a base human, right? Okay. So they have here the crowd workers, and then for the analysis, they rank the data into 5 conditions, into five. The rank into five, like based on the believability. Oh my god, believability. And how they rank this? Basically, they use this true skill ranking, which kind of similar to Elo score, but trying to rank a group instead of just two direct players. I guess I'm not so sure how that works, but basically, it works on the ranking of the characters, right? So here you can see that the full architecture is getting the best ranking, so it's the strongest in comparison to the others. And then you have humans, kind of the worst, but then you have here each part that you remove does degrade performance. They try to run some statistical tests here, like a Kruskal-Wallis test. That's kind of similar to ANOVA. So basically, like how you compare different averages of different groups, some way, right? So like, oh, is this really better than the other, or it's due to noise, this difference, right? So the results is that the agents, they with all the proposed architecture generate the most believable behavior. And then they say here that the Kruskal-Wallis test proves the statistical significance of the paper, no, of the architecture. Sorry. And then here they talk a bit about some issues that they had with the agents, right? But first of all, they're able to remember the stuff kind of correctly, right? Oh, do you remember about the party? Yes, I do remember. And they talked to Isabella and stuff like that. But they have some flaws, right? So have like, which I think is kind of believable in some way, because we have some agents that they actually receive the information about like Sun is running for an election, but when they are prompted, they're like, oh, they didn't remember that he was running for an election, or the party, right? Or like, oh, yeah, I guess there's a party, but I'm not so sure. Which I think it's kind of believable, but not because of the architecture, but it's more because like sometimes you're not paying attention, right? You forget about stuff, right? So it's like you don't care, like guy running an election. If a person asks to you like, oh, I'm running for election, I wouldn't care, like even just like for a relative or something like that. But if it's a person that like a neighbor, I like, oh, okay, ignore that. So it's kind of believable unintentionally, I guess. And then the agents hallucinated sometimes with their knowledge. They fabricated some stuff, right? Which is an issue. But I think the funniest part here is that they also embellish their knowledge based on the real world knowledge that they have from ChatGPT or the large language model, right? Because then they asked Yuriko, an agent, like to describe her neighbor Adam Smith, and then she described the Adam Smith as the economist who altered wealth of nations, right? Really, like it has nothing to do with the Aiden's bit agent, right? Because it's 18th century. So I thought that was kind of funny. Uh, Another conclusion that they had is that reflection was really important. So to make more believable set of actions. So like you have that inner thought in the mind, I guess, of the agent really helped to make more believable actions. Okay, so about emergent social behavior. Oh my god, I already over time. Sorry, guys. But about emergent social behaviors, like I said before, they're trying to get information diffusion, how they start to new relationships and coordination, like to participate in the party. So basically, they measure like how the information is spread, like so they ask all the agents like, did you know that Sun is running for mayor, or did you know about Isabella Valentine's party? And then basically they ask the agent, and they also verified here for every response. They verified on all the prompts, the logs, if that information actually happened, right? If the agent didn't just lie, like, oh yes, I know, but he never talked with Isabella, right? Okay. And then they confirm, the hallucination of the party. And then to measure the formation of new relationships, basically they imagine like the graph that is initialized, right? So you have 25 vertices, and then they have some set of relationships that are already know, right? Of the household, the family household, right? So the father knows the mother, then knows their son, right? But there are other that they not don't know each other. And then they try to compare how connected the graph was to how connected the graph is now, right? And then about the coordination, basically they try to see like who heard about the event and who actually participated on the event at the end of the simulation. So basically here they go to results. So basically like for the 2-day simulation, like the people that knew about the election like went from one person to 8, and who knew about the party went from 1 to 12 people, right? They also noted that here the community of the graph increased from 0.16 to 0.74. So the graph was really much more connected. And then they have like some evidence of coordination for Isabella's party that actually, 12 people knew about the party, and actually I think 5 people actually showed up to the party. So that shows that they were able to coordinate and actually participate, and they updated their plans, say like, oh, I should participate on the Isabella's party that is later today, and stuff like that. Okay, yeah, so basically here's the information goes, right? So here you can see that Isabella talks directly to people, but then they also some people that talks to other people about the party. So it's not only Isabella that is spreading the information. You can see like some second order information diffusion. Okay, so they have some errors here. The first of all is the memory that is a challenge, right? Because you have more space to do, and then they also have like if the agent knows more about places, he will be able to get to make his actions in new places that may be not that realistic. So that's a thing. They also noted some erratic behavior based on what is, again, previous knowledge from the LLM, right? So one example that they have here is that, you have the college dormitory, and then you have a bathroom in the dormitory. And they designed the bathroom here that only fits one person. But since, the LLM kind of guesses that a college dormitory is in a bathroom is a very large one that has several, like, places for the people to use it. Like lots of people start to enter the bathroom, right? So they're not aware that it's like a kind of weird that that shouldn't happen, right? So maybe, but this could be added with some more find prompt. And then here they observe, I think the most important part here is the like effect of instruction tuning, right? Because since they described here in a very polite way, a very simple way, all the agents seem overly polite, right? It's like the example that they talk about the interaction between the family, that they talk like robots. And they also seem very cooperative. So they're more cooperative than usual, right? Always the person tries to talk about like, oh, I want to help you. So that's kind of not believable too much, right? And then over time, this politeness was increased so much that some interests of other characters start shaping the other agents, right? So here, like, have here like Isabella is prompt like she like English literature. She like, yes, I'm very interested in literature, but actually, actually she got this from other person, right? Another agent that knows about literature. They talk to Isabella, and then she's kind of got to know about it, which is a bit believable in some way. That like, oh, if you can show some books and person can get more interest in literature. But for a 2-day simulation, of course, this is an issue, right? Okay, so they go into discussion about how the future can be. Like I said, like the agents could be used to fill metaverses that are more believable, set of actions. So you don't need just human players, etc. That could be used to training new people, etc. Um, some limitations of the work here. They said that just running for 25 agents for 2 days cost thousands of dollars. So that's a big issue. And they also right because it costs a lot for them. I don't know how it costs now with the price dropping. And also here the time scale was too short, like it's 2 days. So they're able to see some emergent social behavior, but how that work over time? That would new stuff come up out nowhere, or would just be great as like a chat GPT chat, right? You get a chat, as longer the chat goes, kind of gets worse and worse, right? So would that happen or no? It's not clear. And they also say about the how they didn't check about robustness of the agents, right? So it may be, like what if you have a user and then the user start to write saying bad stuff, and then all the agents in the simulation start behaving like a Nazi thing, right? I don't know. That could happen, right? Because there's or not, right? It's not clear. They talk here a bit about the ethics and social impact, like, oh, okay, that's interesting. But I think since we are over time, I think we go to the conclusion that basically the paper introduces generative agents that kind of perform some believable human behavior, but at the same time have some lot of stuff to do, right? They are kind of robotic in some ways, but they're able to do, like, I think the most important part here in the paper is this emergent social behavior, right? So you have like one person knows one thing and he wants to organize one thing and he's able to organize, and the other agents know about the information and participate. So I think that's really interesting, really promising on how we deal with it in the future, right? But then again, I think just to finish, I think like some more parts could also add some simpler stuff could be added, right, to make agents more believable, right? So like for the scene stuff, like, oh, the agents, if they could have a score like how they are acquainted with someone or not, if they are enemies, right? So maybe they will not be as uh nice to each other, or especially the needs, right? So have some needs. Maybe some agents are more get tired, some agents get to do some stuff. So maybe they have a new set of actions that maybe are more believable if you try to model them, even if it's a simple modeling, I think that could happen. Yeah, but I think that's it. The last thing to add, sorry guys, but it's that this paper is kind of famous. I think it kind of started a new trend in models using LLMs, that they have the paper and then they create some art out of nowhere that's kind of not necessary. So have like this, and then this other, it's really clearly inspired by the paper, right? So have like all the agents, they interact in the environment. So I think, I don't know, I think that was funny, at least like art becoming more part of the paper, right? But yeah, I think that's it, guys. So sorry that I went a bit over time. So any comments or any questions, guys? Oh, Gabriel.
I just wanted to add, since you touched on the memory thing, like uh, in general, not only on this paper, one thing that kind of bugs me is the need of being explicit that in general LLMs present. Like they, if you don't explicitly, it's like prompt engineering, right? If you don't add explicitly the information or fine tune something, then they get lost. And
Yes.
it seems like in this case, like with the memory thing and hallucinating and like describing Adam Smith, the neighbor, wrongly showcases this behavior. So this is always on. It's sometimes it's on my mind when thinking about LLMs.
Yes, yes. Yeah, I think that's one very important thing, right? I think one thing that helped this paper, the implementation here, is the reflection part, right? So it's like they don't add new information, they just add the previous information. Like, try to, what's important here, But also another thing is that over reliance on LLMs, right? Because the part of reflection is based on that's like how important this is, or the planning is like how important this memory is, or how should we plan next. So we also
Yeah.
have a over reliance, so that like you said, maybe if it's not specific enough, uh, I imagine that maybe potentially like as the simulation continues, everything kind of gets stale, right? So like,
Yeah.
oh, people talk like, how was your day? The day was great, thanks. And then like they go to
Yeah.
work and then they go back. They are, how are your day? They're great.
Yeah.
Kind
No. Yeah.
of maybe that should happen, right?
Yeah.
But yeah, I think it's an interesting point, right? How the you know
Yeah. You
make
and
more.
what happens like if the LLM hallucinates during the reflection, right?
Yeah,
Uh,
yeah, that's an issue as well. Yeah,
yeah.
that's a,
So
it's a short time stamp, so maybe they
yeah.
didn't saw anything. But that could be a thing, right? Like doing a hallucination of reflection, like the Aidan Smith guy could become Aidan Smith, the economist, and then he
Yeah.
start preaching capitalism to everyone. That would be
Yeah.
fun.
That would be very interesting. Yeah.
Yeah, yeah.
Cool.
Okay, guys. Any other comments or questions?